Hello guys, we'll be looking at part A, third experiment, which is about the Schmitt trigger. You have to be designing a Schmitt trigger for the given values of UTP and LTP, for which you'll be doing it in the design part. You'll be getting the V reference value and R1 and R2 values. So the design part goes like this in NI multisim. Firstly, you need an op-amp because a Schmitt trigger can be implemented using an op-amp. So the op-amp number is 741. So you select it and drag it here. So the first step after you have got the op-amp is to flip it vertically, as you have done in the last experiment. So flip it vertically. So this is how it looks. After which you need four main components again here, but the components differ. So you'll be needing two resistors that will be available in the basic option, and resistors, one of 1 kilo ohms, R1 and R2 of 9 kilo ohms. So got the resistors, after which you need the DC power supply. You'll be needing 3 DC power supply here, one for pin 7 and one for pin 4. Other than that, you'll be needing one for V reference. So 3 DC power is required. 2 of 12 volts each, and the other one will be according to whatever you've got the V reference value. Then you'll be needing a AC voltage. So this is how it looks. This is AC voltage. After which you'll be needing the ground connections. One for the AC voltage end, one for the R1 end, and the other one for the 7th pin and the 4th pin. And you need another one for the oscilloscope's negative terminal. So the fourth option is the oscilloscope. You drag it here. So these are the components. Now you have to do the connections. So firstly, the pin number 2 goes to the AC voltage. This is AC voltage. This is pin number 2. Then another end of the AC voltage should go to ground. So you just connect it. And you have to remember, you'll be calculating voltage peak to peak of 10 values. So you'll be making this as 10 volt to peak voltage is 10 volts. That is why. After which you need R1, which is one end to R3. Other end would go to V reference. So you have to change it to whatever value you've got. For the design part, we've got 3.3. So connect it here. The other end goes to the ground. After which the R2 resistor goes in between the R1 resistor and pin number 6 as usual. Like in the last experiment too, it was the same. After which you have to be doing the DC power supply for the pin number 7. The other end of DC power will go to the ground. So just have to connect it. Then pin number 4 has a DC power supply again, and this has to be rotated. That is Control R, and you'll get this. After which you have to do the connection. That's it. So this is about the circuit connection. You have one more connection remaining, that is the oscilloscope connection. So you just have to short the negative terminals, then you have to connect it to the ground. So just connect it to the ground. In positive channel, the B channel's positive terminal would go to pin number 6, and A channel's positive terminal will go to pin number 2. So this is the circuit connection, the whole circuit connection. Then you have to run it. So just run it, double click on the oscilloscope or CRO. You get it like this. You have to make the scale to 1 milliseconds. So you get the graph like this, and you have to pause it. So we have done UTP for 4 and LTP for 2 volts. So you have to be checking that in the output. So the end where the capacitor waveform crosses the rectangular waveform upwards will be considered the UTP, and the other one to be LTP. Just drag it. You have to get, in channel A you have to get 4 volts and 2 volts. So just drag it wherever you get it. Approximately is also fine. So we've got it. The upper one will be the UTP, the lower one will be the LTP. So maybe here, not in that. You won't be getting exactly, but you'll get approximately. So you have to be taking it in one square way, only one square only. Can't be taking somewhere else and all. So the channel A first value is about the UTP value, that is 4 volts. It is approximately equal. So the second value is about the LTP value, that is 2 volts. That is also approximately equal. So this is about the output. Thank you guys.